Yeah.
Yeah.
So my name is Pavel Chunyayev, and I'm continuous delivery architect at Live 9 IT Services. Today I'm going to talk about versioning and branching, and I don't want this to be just presentation because it's fun, of course, but I'd rather engage into some discussions. We'll see how it goes, but generally it will be 3 parts. First part, I will quickly talk about my view on continuous delivery. Yeah, being continuous delivery architect, you have to listen to me. Well, sorry, but I hope you will like it. Second part, I will talk about versioning, and this is where, well, I would like to hear from you. What kind of versioning schemes you are using, and I will describe what I experienced, or what I've seen people using, or what I've read on the internet, of course, or what I think might be useful. But anyway, ideas come from all sorts of sources, and I hope also to get ideas from you. And the final part is branching. It probably will be the smallest because, yeah, it's very, very deep. But I prepared some of the branching schemes I've seen being used, and I will, yeah, describe them, and we could have a discussion. Yeah, questions are welcome anytime, and disagreements are welcome anytime. And yeah, comments, everything. Let's yeah, get into some discussion. Quickly, so I work for a company called Live 9. We are a software development company, 700 people, mostly in Ukraine, Romania, Serbia, with the head office in the Netherlands. We work on the Dutch market, mostly for the Dutch customers. And in 2015, we got 100% customer recommendation score from Giarte. Yeah. Quickly about me, 12 years of IT experience. I come from Ukraine. I also used to live and work in Estonia from 2007 to 2010, before I joined Live 9 in Ukraine. And then in October 2014, I moved to the Netherlands. And so far, I like it here a lot. Yeah. I love cycling. Well, I discovered that I love cycling after I moved here. Before I wasn't very tall. This year I'm going to do second time Alpe d'Huez. The idea is that you need to climb the mountain on a bicycle 14 kilometers. Last year I did it 1 time in 2 hours. This year I want to do it 2 times and maybe faster than 2 hours. We will see. If you want to donate money to fight cancer, well, you can do it. Finally, I'm learning Dutch, and well, I like it. Also, it's hard, it's a nervous experience, but I get better with this, so spreek Nederlands met mij. En misschien een beetje langzamer, en je kan makkelijke woorden gebruiken, maar ja, jullie kunnen mij helpen. En ja, het is zenuwachtige ervaring voor mij om in het Nederlands te spreken, en ik ben echt bang ervoor. Ja, maar ja, jullie kunnen mij helpen. En het is mijn droom om gewoon in het Nederlands te spreken.
Prima.
Heel goed.
Okay, yeah. Now, quickly, continuous delivery. So, different people think of different things about when they hear continuous delivery things. When I hear about continuous delivery, I think of something like this. This is all the steps that actually need to come in the process and need to take in order to implement a feature or any idea. It starts with the inception, where we want to, there is an idea that, well, will bring us money, hopefully. And then it goes through planning, development, building, testing, releasing, and operation. And this is where we validating the idea. And one of the things here is that not every feature is actually needed. I can't recall the real statistics, but it was something about that 1/3 of the features created by developers are not used by users. And this is a waste of time, this is a waste of money, this is a waste of effort. And so the thing here, and why I'm talking about pipeline continuous delivery, that we want to, when we come up with the idea on this inception stage, we want to quickly go through this pipeline and validate is idea is something that our users need or not. And this is why people start talking about shorter and shorter release cycles, about how quickly we can go through the whole pipeline, about cycle time, about lead time. People are bragging about the number of commits a day, or at least, well, lead time. But yeah, and we need to kind of this release cycle is getting shorter and shorter, and we need to release more software in less time. But what I also say is that it's not only about speed, it's more about quality. And this is the crucial part that I think is always forgotten about continuous delivery. Let's quickly churn out things. But if you do it without arranging the quality, you will actually deliver defects or regressions all over the place. And yeah, you need to change the way you're doing this if you want to gain speed. If you gain quality, speed will come as a byproduct. But this is one of the things that you can't rely on manual testing anymore to establish the quality, because you need to do it at scale. But what you need to do is these two ideas. You need to keep the product releasable all the time. After every commit, you need to keep it releasable. Otherwise, well, when do you do it? And you need to build the quality into the process. Again, you can't arrange the quality or ensure the quality afterwards. It needs to be part of the software development lifecycle. Only then we can keep the product releasable, and only then we can do it at speed. I think we need to do it through the build test release cycle. What is a build test release cycle? Well, it belongs here. And this is actually what most of us experience in our daily life, or not we, but developers. Well, we go this. And okay, this is the big pipeline continuous delivery. Okay, it starts with the product management, maybe, or with those guys who can generate ideas. But for us, for technical people, well, we go here, mostly here. And how it looks like. On one side of the pipeline, and this is a real pipeline that we do in Jenkins, we throw in the source code. This is why the branching is important, because this is where it all starts. We'll talk about this. On the other side of the pipeline, we magically get a working software. What goes through these stages? So build stage, everything that makes sense to do with the source code. Unit test, static code analysis, static security code analysis, linting, whatever. At this stage, we also package and version the software. This is why the versioning is also important here. Then we go to testing. And testing, yeah, a bit of a view, my view on testing is that we need to do all the testing that is required to ensure the quality of the application at one stage. Just these are testing. You can think of this as a set of criteria that if we match those, well, we stamp the application quality assured. Yes, here you are, guys, and we go to the release stage where we make our application available to everyone. But how do we do it? Well, immutable infrastructure. This is, I believe, what's the way to go. I don't believe anymore in a DTAP, or the concept when you create software, you deploy it to development environment, then to test environment, then to acceptance, finally to production. I believe all the testing needs to happen in parallel and all together. And if, for each kind of testing, we first create infrastructure, we run those tests, and then we dispose infrastructure immediately. So there is no concept of development, test, and acceptance here. Any of those can be development, test, or acceptance. And if we create infrastructure in the same way, we do it on developers' laptop, in production, we do it everywhere in the same way. And then we don't need to have a dedicated service for development, testing, and acceptance, because we can have as many of them as we want. Okay, if we've got money to run those in AWS or locally, but generally, it is the price you pay for testing. Or you don't pay, and then you pay somebody to manually test, but then we're not talking about speed or quality or any of those things. So, yeah. Ideally, I would say there should be a testing framework that should take care of this. So they should provision infrastructure, then run the test and dispose infrastructure. That should take care of parallelism. Okay, I want to run this end-to-end test in 5 flows, for example. One of the interesting things that can help establish parallelism is a concept of time to live of environment. If you say that you provision environment, but then in 1 hour it will be destroyed, well, then somebody needs to take care that after 1 hour the tests are finished, or you need to split them into 2 flows or 3 flows, so we can provide quick feedback to developers. Because, well, late feedback sometimes is even worse than no feedback at all, because there is a context switch in there. So this was, yeah, a general view on continuous delivery. Now, let's move into version. So, versioning is one of the fundamental things, and if you think of this as a version, everything. So when I first got acquainted with computer, it was Windows 3.11. And then Windows 95 appeared, and everyone knew 95 is better than 3.11 because it was 1995. Then a couple of years later, Windows 98 appeared, and obviously 98 is better than 95. So we use versioning to send a message. Okay, there is something new happening here. We got a new version of our product. Just prepare your money. We don't change the name, because we want to say, this is the very same product that you got used to use. But, well, it's a new version of it. It's new, updated, shiny, with all these bells and whistles. Or, on the contrast, we want to change the name of the application, like Internet Explorer is a famous example, probably. Just, how it is called now?
Edge.
Edge, yes. So, Microsoft decided to change the name to send a message, well, this is something new. It has nothing to do with all this legacy of Internet Explorer. No, no, no. New stuff. So, well, and same is all over the place. Another example is Web 2.0. There was this thing in 2007, 8. Yeah, it has nothing to do with Web 1.0's static content. This is the user-generated content. We're talking about Web 3.0? No, I've never heard. Well, then in 2008, I heard a lot about this. And nowadays, nobody has this concept. Same with the movies, with cars. Well, we use versioning everywhere, and we use it for software as well. So there are a couple of models that I see, and a couple of schemes that people are using. First of all, I want to really differentiate between SaaS and installed applications. Because, well, if you're running SaaS, you don't need to care about bug fixes and hot fixes. Actually, you care a lot less about versioning if you're running SaaS. Because it's something that you are doing internally. Like, you probably don't know which version of Facebook are you using, or which version of, well, any other SaaS that you're using. You just don't care. It kind of updates, it's under the hood. Internally, developers do know about this, but for users, it doesn't matter. On installed applications, it's completely the other way around. You need to communicate this to users. So you need to create a version scheme that will support you in this journey. This is what I see different models. Numeric model, I will talk about those indeed. A date-based semantic version and marketing version. Okay, first of all, does it sound familiar until now? Good.
I do have a lot of questions about your previous bit, but
after the talk.
I'll get to that.
And in Dutch.
And in Dutch, yeah, definitely in Dutch. Easy word and slow.
Yeah, okay. Numeric. So generally, most of us experience this in these guys, major.minor. This is at least how I see it. And again, my historic example, when I started working, there was FreeBSD version 4.11 and 5.2. And well, everything was simple. 4.10, now the new version 4.11, and 5.1, version 5.2, everything was fine. But then another thing appeared. Version 5.2 had an awful flaw in it, like really, really awful, some kind of bug. And then there was a version 5.21 released. And this is immediately introduces you to the patch level of the whole story. Or for example, if we're talking about iOS, the latest version is 9.3.2. Also, well, no new features, but some bugs are fixed, and so on. And well, a lot of other possibilities here. We can add the build number, well, we can just forget about patches. Add build number, or add revision if you want something, or add even date if you need it. But generally, yeah, it looks like those, and this, I believe, is most widely used scheme on the internet. This is how people are doing this. Just one big note here is that, well, in Java, and well, I mostly do Java, this is what we face a lot of times. And you should not use this guy called -snapshot. Especially not if you're trying to reach continuous delivery, because well, you need to version each package separately. M1 or C1 release are fine, but not snapshot, because the problem with the snapshot is that this how they look like. The problem with the snapshot is that you're producing artifacts that are called the same crosses your cycle of development until you can release. Anyway, and this is wrong because you haven't got mechanism to differentiate between different builds. And this especially goes wrong when you've got a complicated integration structure. If you're developing a simple product, it will work. But if you're creating libraries, building blocks, and then assembling into one product, this won't end up well.
What's your opinion about using snapshot versioning for external purposes? Like you have a build, and internally you have like a build number, which 30-digit and counting up. And for your external users, you can have a nightly build or a snapshot build or whatever.
So why would you call it snapshot?
Well, because it's a snapshot of the...
And then you use provide a bug report in version 1.0 snapshots, things is not working. Is it from today, from yesterday, from 3 weeks ago?
Well, there's a difference, of course. If you use the naming, then it works. But if you use the Maven way, then this is not the version, then below the snapshot there's a timestamp.
Yeah. But then it's hard to reason for everyone which exact snapshot will you get. Yeah. This is my story. So, and this is why it's not that I dislike Maven, but Maven exposes this life cycle, and it was created early in 2000, and it was breakthrough then, because it provided great mechanism how you would develop software. But now in 2016. I don't believe we should use the snapshot anymore, really. Yeah. But anyway, who is using something like this? So it's not semantic version, it's not anything else, but just, numbers. Anyone? No? No one?
If you are using numbers in that?
Yeah. Which exact, so if we think of this, which exact you're using?
None of them.
None?
No, because ours are based on our sprints. So we used to have 4-week sprints, and we started counting in 2009 something. So basically we are sprint 96 now, and then we have an instant fix, and we have a day of the sprint. And
wow. That does not sound complicated at all.
It's very simple. And
96 sprints ago, it probably was very simple.
And
volgens mij zoek je deze.
Ja, dat is ook wel handig. So, it started to get complicated, and we have now simplified it to some, basically the same numbers at this moment, but we start to get rid of the versioning at all.
You get rid of versioning completely?
Yeah.
So how would you discriminate between versions?
The Git reference.
Your Git reference, holy crap. Your tag or commit reference?
The commit reference. Because
that's like a 32-bit string.
Yeah, because we don't care for the versioning anymore. In the current release process that we are creating, we are going to production as soon as you merge to master.
I will talk about this shortly, but this is one of the interesting things, because really sometimes you don't really care about the sequence of the builds. I mean, which one of them was later. You need to identify them, and then git commit hash is okay. Why not? You can't think of those which is younger, which is older. But if you don't care, and then you don't.
The simplest case to get a view on it is that stuff that's on master is on production. That's it.
Yeah, okay.
That's the version. If you want to know the history, you look back in the Git history.
Plus, you're also not providing an install piece of software, right?
It's
just exactly.
Again, it's easier with SaaS. There is a production, and that is harder, but it's easier from the version perspective and a lot of other perspectives. Yeah. Okay, anyone else to add on the version? Something interesting?
Our little team within Triple is a Microsoft team, so we're outnumbered here. Microsoft for the longest time promoted the third one, so the major minor patch build version.
Okay,
and more recently started to migrate to Stanford.org, so basically the line about it.
I will talk about semantic versioning shortly.
Yeah.
Okay, well then quickly. There is a problem with the change in version of the scheme because the scheme doesn't mandate any rules how you would do it. And then one of the things that I see is that, well, software will never reach 1.0. Like a lot of pieces of software, especially in the Maven world, are stuck in 0 point, sometimes 23. Versus even, I think, is something like 0.29. So I can't recall the latest version, but it's used in production by so many people, but it's not 1.0. So, and this is why, well, how do you change the version? This is the big question. And another example is that rapidly increasing version. I've got an example of Firefox. So when Firefox appeared in 2002, what was the version of 0 point something, and it took 2 years for Firefox to reach 1.0. Then it took another 4 years to reach version 4.0. And then at the same time, Chrome appeared, and it took Chrome 1 year to reach version 4. And so there was Firefox that was already 8 years on the market, and it was version 4. And suddenly Chrome, there was 1 year on the market, version 4. And the message is, well, they are the same. Version 4 is the same. And then Chrome started increasing. I think latest version is 52, and the Firefox is 54. So, but then again, probably now it is hidden because nobody cares about the version of the browser is being updated automatically. But then, again, there are no good rules. Firefox started incrementing the first number because Chrome started doing this, and it looked bad from this perspective. But there are no good rules. Quickly about date-based, I don't think it's really widely used, but a lot of people, well, I see still doing this. Well, and then produce something like this, like well, you have a year, a month, and you have a date, and then the build number 1 of that date. If you plan to do more than 10 builds a day, well, you can add 2 numbers. If you're a lucky one and you want to have more than 103 numbers, well, probably nobody will have more than 1,000 unless you're Google or Facebook, but, well, it can happen. Or you can differentiate by timestamp, again, hours and minutes. You probably don't need seconds, but well, you can always add if you want. Yeah, here you are. And or just don't have major and minor, or have something like this. Mostly I've seen this again for SAS when you just need to add something, and date is a perfect thing to add. Somebody using date?
Well, basically our version is kind of a date.
Mm-hmm. Well, but it's based on sprint, but it is date.
Yeah.
Sprints, but yeah, it is date. Anyone else into this?
Yeah, but it's not common.
Well, I've seen a lot of, in Java world, a lot of things, version like this, well, not with the exact thing, but not, I mean,
It's
with
just
minutes.
usually internally, I see this a lot more often than I do for something that's external, just for readability. So you can pass it to your marketing team and they know exactly what they're looking at.
Oh, I will talk about marketing as well. Anyway, then let's move to semantic version. And this is semantic version. It looks more or less like thing we discussed, major, minor, patch, dash, pre-release, or plus metadata. But semantic version has exact rules how you change the version. And this is both good and bad. First of all, why it's good? Well, it looks something like this. When you create a bug fix, you just increment the version or well the patch, and that's it. Super simple. You can add a lot of information like build number here or some hash of the git commit. If you introduce a backwards compatible change, you increase the minor and reset patch to 0. If you introduce backwards incompatible change, you increase the measure and then also reset everything to 0. While your application is in development, you use 0 and upfront. When your application is ready, you immediately switch to 1.0. And of course, it also talks about APIs and other things, but effectively, the semantic version provides you a scheme how to increment the version. And this is also sends a message for everyone who is consuming your product. Okay, a previous version was 1.1, now it is the version 1.2. Probably it's a change, but it's a backwards compatible change. You can probably more easily change it in your dependencies and everything will work as is. interesting idea is that if you develop application correctly, and also if you develop public API correctly, it probably should never go beyond 1.0. Should, I say, because if you created correct domain model and correct API, you shouldn't change it. And if you have a popular product, probably, yeah, it's also expensive to change. Companies are doing this, but yeah. But then still, if we will forget about public API and those things, semantic version provides you a framework how to increase the version. However, there are still a couple things, and especially if we're talking about continuous delivery. Because, well, when do you assign a version? When you start working on a feature, or when you tested it and you release it to public? So semantic version works perfectly in a manual process, or for open source world, or if you're one developer. You're thinking, okay, now I'm releasing a patch. You're bumping up the version, here I am, doing stuff, commit, here is this version. But if we're talking about a big team, how are we doing this? And when we are changing the version? And if several people are working simultaneously on one product, but on different features, for example, and patches, how do we arrange working with the semantic version in here? But also, well, are we enforcing the sequence of pull requests? So, for example, if the version was on 0.5.0 and I'm implementing new backwards compatible feature, I'm bumping up the version to 1.6.0, and then I'm working and creating a pull request. But then, in the meanwhile, somebody can create a patch for 1.5.1, and they also create a pull request. Now, somebody needs to take control of this, and well, know what happens when, or create a set of rules. Semantic versioning is, I say, a bit tricky with continuous delivery, and also it's not needed for SaaS, like at all, whatsoever.
Well, there is a difference between the application or SaaS versioning and the API versioning.
There is right. However, I claim that we don't need fully semantic versioning for API. At least I don't understand what does patch mean in API. Measure.minor, perfectly fine. Patch? No. But again, we can have models or schemes that are inspired by semantic version, because again, the rules are clear, but don't follow them closely. However, for example, this can be a problem for front-end developers, because if they want to use NPM, they have to use semantic versioning, otherwise, sorry, you're out of luck. So it is true. And also some people say that if you would try to use build numbers, so if you think about major.minor.build number, they say it's abuse of semantic versioning, and this is of course true, because then as the result, regardless of what you change, the major, the minor, patch will never be reset to 0. For some it is a problem, but if you use this internally it might not be a problem at all. But if you communicate it to customer, oh, it's a version 1.5 527. You had 527 bugs and you fixed them? We don't want to do anything with you. You release buggy software. So, yeah, it can be tricky as well. But also the problem is interesting, another one. How do you identify what is backwards compatible change and what is backwards incompatible change? It's up for a developer to decide, but in many cases, what for some is backwards compatible change, for some is backwards incompatible. And this is also something that, okay, it's a nice story about semantic versioning, but okay, it's not a big deal if you mess it up. But you need to know that, okay, this rule's not cut in stone. This change is backwards compatible, and this is not. And also, yeah, if we think about integrated applications or collection of applications, how do we change the version? If just one of the collections of object we increment the measure, do we need to increment it on the results of the application or not? Maybe, maybe not. Semantic version rules don't tell anything about it. But still, they're nice. And I would advise, even if you don't use semantic versioning, well, at least use the rules to increment your major and minor. Anyone into semantic versioning right now?
Yeah.
How do you use it? Maybe you could share a bit.
How we use it, basically straight up the way it's dictated. So whenever we build an API, which is mostly what we use it for, we dictate whenever we add add new features, a minor version is released. Whenever something breaks, we make sure we release a major version basically. And bug fixes, like you said, don't really apply a whole lot. I find your observations very fascinating, especially the what defines backwards compatibility in the context of a bug. You know, people that consume your API might be aware of the bug and might have programmed around it, and then if you fix it, that might actually break their implementation. So, yeah, like I said, we're basically just straight up the way the semantic versioning was envisioned. That's how we try to apply it right now. We've only started doing this fairly recently, so we haven't really ran into too many issues yet. But what you're sketching here is definitely stuff that we're going to run into sooner or later. So please, please keep going.
So how rapidly is your version increasing, and when do you determine when a new version needs to be made?
How rapidly? Not very rapidly at all at the moment. So when the APIs that we're delivering right now are not very commonly. I mean, we might have 2-3 client applications from agencies that consume our API. We have customer requests that come in every month or so. So our version numbering isn't increasing at a very rapid pace.
APIs, those can not sort of need this kind of elaborate scheme.
No, exactly.
I was wondering how rapidly it is increasing, and when you actually determine when you need to increase it.
Exactly. Well, usually it starts off with either a bug report from a customer or from a client application, their implementer, or our client that's paying us to build the API. They want new features. For sure, we'll increase the version number and go from there. But it's not like we build it daily or anything, or we don't have thousands of clients consuming our API.
What kind of API are you talking about? Is it like a REST API thing?
Yeah, basically. When I showed one of our customers, Heineken, has what we dubbed logic APIs. So they have a number of brands of beer, and any brand of beer could use, say, they all need a customer contact form. They all might need an age verification system. They all might have codes that you can enter so you can see if you can win something. So those logic apps are centralized to make sure they all, of course they have their own data sets, but the logic is centralized, and Desperados and Heineken, Amstel, they might all consume that one API every single website. That's an example of what we built.
We also use the SAM versions for the libraries and the API drivers, and the major minor version for the APIs.
Perfect. I will talk a bit about APIs after the marketing versioning, and I would give some reasons about it. So marketing versioning is actually, well, shortly, wherever those guys decide.
Super version 2000.
Yeah, and well, something like this, or well, also exactly, wherever they think they need. But then, the problem here is that how often to release and how often to increase the version of the number. And also, if you think of this, marketing guys won't agree with continuous delivery at all. Because the continuous delivery says, well, let's deliver tiny incremental changes. And marketing says, well, let's market our changes. This is a huge new feature. And the idea is that, well, they don't have anything to reason about, to sell to customers. So actually, marketing guys are the ones who want to release less frequently. Okay, we've got feature toggles and other things to help them doing that. But actually, there is kind of not control, how to call it, marketing and delivery are against each other, in a way. But then, it happens, and we need to go with it. Quickly, something about how we generate and save version number, well, into the source code. obvious the first thing, especially if you use semantic versioning. There are some, well, it can be a problem. Again, when do you increase the version? Before, after, who is doing this human script? And if it's the script and we got continuous delivery pipeline or continuous integration pipeline that is triggered by commit to Git, how do we exclude it? A lot of things, but it works for a lot of people and it's fine. External, and this is what we're talking about, date, build number, or source control hash ID. Again, these are the means or the sources of, well, how we can differentiate between the different numbers. Yeah, how we bump up the version before or after manually. I was talking about this. I'm more interested about the last part. Who is doing this, who makes a decision, and when in the process it happens. For those who are not doing this with the build number, source control, or date. Or how do you change the major.minor even if you are doing this? What is your experience here?
Well, we have two ways. So for libraries and APIs, we do it manually. We commit the version number.
Well then, yeah.
Yeah, just because everything is done in master for libraries and APIs, and if it's committed, it's automatically deployed for that version. And for applications, we during the deploy process, we generate the version number based on spec.
So you don't save it anyway; it's just generated. So you don't save it in the source code. Okay.
Yeah, we might tag it.
Tag this point.
We do it manually as well. I read the other day where Stack Overflow uses Slack to claim a version number. I found it quite interesting, intriguing actually. So we might, just for the heck of it, we might switch to that at one point or another. It's not like we have hundreds of developers fighting for version numbers, but it's just, no, so far it's just manual.
Anyone else to share?
For the marketing version.
Huh?
One step back for the marketing version.
Oh yeah, sorry,
So
I didn't. Yeah.
How do we take care of it? Well, what we do for our product, we have an internal development project which is called Meetup, which basically every time we merge master, it's released, it deployed to production.
Yep.
And what we do, we have every month we have a kind of demo, and in that demo we describe what new features have been developed in the month. But every time that we release a new version, that's well, basically every change that we get, that we implement is requested by a user, so that user already knows when it's deployed that it's there. And during the demos, we notify all the other users that it's there.
Okay. And then the price goes up once a month?
No, it's internal development tool.
Okay. Thank you. Then, what to version? The product, obviously. All the separate applications that consist of the product, or all the libraries, building blocks, and tools. Also, well, even private tools we have to version. Even if there is external versioning or marketing version for external tools, your private tools need to version. And you need to know, okay, if it's a version 2016.6 or whatever, Ultra, you need to know internal version of it, because you won't call those names internal. But also APIs, and this is the most important part. Regardless public or private, you need to version APIs, and the more I work, the more I think that this is the crucial part. Regardless monolithic application or monolithic architecture you're having, or microservices, this is the crucial part that a lot of projects are missing, and these problems when the projects grow. Database schemas, again, a lot of projects just don't do it. We have to do it. And well, infrastructure configuration. Docker helps to forget about infrastructure configuration, because infrastructure configuration becomes part of the application itself. But if not, but then you're releasing it as a part of the whole product. You tag and you version the product, and then infrastructure comes inside. Well, at least how I see it, because Docker container is both infrastructure and the package kind of connected together. And this is why one of the benefits of Docker, why it conquers the world. What else here I want to say? Oh yeah, how do version things? So there is kind of two worlds. One is embedded meta information, and what is called Microsoft world, because the files are called the same, but then you have meta information with exact version, or the file name when you have a version exactly specified in the file name. Both are good and bad. If you have the version in the file name, you need to prepare your script to accept that, expect that, sorry, and then base everything around that. If you use it embedded, well, the file name is always the same, but you need some kind of tool that will allow you to read this information. Both are working, but then you need to know that these two things exist. Oh, this is important. Even if you're working with JavaScript or PHP or Python, package the code and assign a version to package, to the binary, to the artifact. Don't version, well, you can version the source code, but when you're working with this in your continuous delivery pipeline, even if you don't have continuous delivery, take the artifact, version artifact, and then make the artifact travel across environments or deploy artifact, because this is the thing that you haven't tested, not the source code, the artifact. So you need to version it. Oh, and dependency management, final thing, well, one of the things why we version, especially for more complex projects. How we do it? Latest, ranges, or explicitly specified. Each one of them has advantages and disadvantages. I can't advise any of them. Latest is fine because then you can catch issues early in the process, and you want to catch them early in the process. But if somebody breaks something, well, other ones will be affected immediately. Again, both good because the feedback loop is short and you find out this quickly, and bad because the work is blocked and stopped. Ranges finally work, especially with semantic versioning. You can say, take everything that starts with 1, but not 2. You're fine because you expected this to be backwards compatible changes. Or say everything that starts with 1.1 and any patch level. Again, we're working fine. Or you even use explicitly specified. You are fully protected there, but you need to have a process how you will update those. Otherwise, after 2 years, you will get with the outdated dependencies. So again, each of them has the advantages and the disadvantages. You will have to know what applies to you.
Basically the same as the snapshot.
Not really. And we don't have a lot of time, but I can argue about that because latest, if created correctly, if you implement the build, test, release cycle, you will never get in a release something that is broken. So latest will be always a quality software, if in short. But then this is a huge discussion.
Which references to a specific version. So.
Yeah.
When you pull, when you use pull mechanism, you will just pull the latest tested, always. Unless again we're talking about changing the backwards compatible changes, but this is a different story. And again,
but from the user side, it's a snapshot. You don't know which version you are using.
It's a different semantics of it. So again, with the snapshot you have no clue, and the snapshot is expected to not work actually for a lot of time while in development. With the latest you expected that it will be always quality software, just the latest version of it. So you take responsibility for something that will be broken, like on yourself, but you expect that it will be always working. Not that it's a snapshot and things might be broken. So this is the difference here. It looks the same, but yeah, it's a bit different. So quickly about APIs. So APIs are the most important part of the microservices on monolithic applications, because if you think about microservices, well, you take some objects or group of objects just separate from the monolithic application and just add networking layer on top of it. But same API is actually applying to monolithic applications. Then, first of all, yeah, I don't think we need full semantic versioning, just major and minor. And if you want to change it, you just can't break the contract. You need to run things together. So you change it, you provide a new version of API. Some people don't even have minor for API because it's not changing. If you invested some thought into creation of API, even minor won't be needed. But then again, I've seen version V1, V2 in some services, V3 I can't even recall anywhere, frankly speaking. Maybe it exists. Well, anyway, 1.1, you announce it. Just guys, start using it. Services start transitioning there. When everything is transitioned to 1.1, you stop delivering 1.2. And actually, I argue that you need to have the same process even if you're delivering a monolithic application. It will just, if you have a lot of teams and they'll get it in different places, it will save your effort to keep the product releasable. Otherwise, well, somebody changed the API, and in monolithic application, APIs are kind of implicit, and it's easy to break those. And suddenly for other guys, it's not working, or the whole application is not working. But it was done for good, but yeah, in the wrong way. But yeah, this is what I advise. And yeah, this was actually all I have about the versioning. And before we move into branching, any other thoughts or things to come up with or to discuss, to mention? Okay, then the branch. We're already 45 minutes. Well, okay, we'll go quickly here. Well, branching is essentially needed because, yeah, they're convenient and you're not working alone on your source code, eventually. And the models here, well, first of all, again, models will be different for SaaS and installed software, really different because the requirements are different. Now we'll talk about this. But I would like to talk about these more models quickly: trunk-based, feature-driven, well, feature branch, release branches, Git flow, and about open source. Again, this is not everything that is covered, but this is something that I think most people will experience, yeah, in most cases. First of all, trunk-based, as simple as it can be. Yes, I believe this might be ideal for continuous delivery. It's perfect. You create a change, you commit it. Here we are, the running pipeline, and something is running in production. Just, it can't be any more simple, and it can't be better. But implementation of this is tricky. Really, I don't know any successful project or big project that was doing this. At least I haven't seen it. Maybe you guys. But my experience that whenever we're having more than a couple developers working, this thing doesn't exist. In ideal world, and in the books, perfectly, or if you teach developers how to rebase and do a lot of things, it can be working. But generally, I don't have good experience with any big project, more than one or two teams using this.
Can you explain what the pain points are then, or why it doesn't work?
I'm not saying that it doesn't work, but it needs, first of all, for developers to understand how Git works, and most developers just don't want to know it.
So that's just knowledge.
I know. Again, this is my practical experience.
Are you talking just keeping it clean?
Keeping it clean,
Yeah.
learning how to rebase, learning how to cooperate with one another.
Only time I've ever seen a clean Git history is if there is somebody that acts as a Git master that does all the commit, handles all the merges themselves.
It can be done like that. Yeah.
Yeah, but that's the only time I've ever seen one remotely clean. They usually look like subway maps.
We'll get to subway maps. Yeah. Well, another issue with this is it only works for SaaS, for the web development. It doesn't work for installed software at all. Well, because you need to support different versions of the application, and it's not hard to support if you're moving forward all the time. At least if you promise the customer to deliver bug fixes, you just can't do it, because you will deliver all these bug fixes with the new changes. And this is tricky.
One more question?
Yeah.
So to connect it to the versioning story for monolithic repositories,
Yep.
like Google, Facebook, they have the whole
Yep.
software in one, and they're also using trunk-based development. So is that something you have any thoughts on, or whether or not this could work for smaller teams? If it's because you're versioning with all the libraries and stuff, if it's all in one repository, you could just use the revision,
Yep.
to sort of version the whole thing at once. Any experience with this or thoughts on it?
So, I've seen this again working, but we need to teach developers to do this. One of the big thing and my trouble with this is that having kind of a full the commit that contains all the feature or you're using the feature toggling, it can work. If I have the tools for developers that can test the source code before even they start with the pipeline and the code review, it can help work. If developers know how to work with Git, it can work. But in most cases, what I see, people move to the branch model that I will talk the next. And it's a lot easier for developers to understand. It's a lot easier for project managers to understand. Just a lot easier for everyone. This is my experience, really. When you go, you read internet, this is the golden rule of continuous delivery. If you read the books, this is the golden rule of continuous delivery. But then, in the real world, again, in a big project, my experience, I haven't seen it working. This is, I am not saying that it's impossible, though. Just, and yeah.
And as far as I understood, Google and Facebook, they also do.
Yep.
Every pull request is basically every change is made on a branch and merged to master.
Oh, but this is this thing. But this is this thing.
Yeah, that's.
So these are a bit of different.
And they don't release directly to production. They have release plans, once or two per day.
I'm not familiar with Indoor, so I've only, well, the biggest examples of monolithic repositories are Google and Facebook.
Yep.
They also have a dedicated build system to support this kind of infrastructure. So it's true what you're saying, it requires a real high level of maturity on all fronts to make this work, and maybe even engineering on top of that. So I fully agree with what you're saying. This is actually the model that you...
This is what I see, well, all the time, actually. And this is what people are convenient to use, because for branches actually the kind of the feature of Git that why everyone started using Git, and this is, well, it's just convenient for developers. You create a feature branch and then you merge it back. The only thing how to make it work is, well, first of all, feature branches need to be short-lived. Really short-lived. I'm not talking about, well, days, not weeks or months, because then they get forgotten and lag behind. But second, you need either to teach developers to constantly pull from master, or enforce this. It can be automated as well. But whenever somebody, well, in this graph is whenever something is merged back to master, we push changes to the feature branches. But it doesn't have to be automated again. But if you can't teach developers, well, you can automate it in this way. The only not fun part of the branching thing is, first of all, if the branches are forgotten, it is a metro scheme, but also you see your history, it's full of merge commits that provide no value. But then you can of course teach everyone to rebase and delete the branches, but this is something by getting back to how to get maturity into development and tools and everything. But this is what I experience most of the time, and I would expect most of everyone to use something like this, actually.
How do you handle the merge conflicts with this structure?
Well, first of all, ideally there should be no merge conflicts. If you do correctly pulling from master, there should be no merge conflicts. This is at least, well, they become a lot more rare than.
For example, in this case, C, D, and E.
Yeah.
Will contain conflicts. Possibly.
It
might, but to see what happens when the feature D, they merge the first. They shouldn't have conflicts because they have no clue about C and E at all. But when they merge, C should, before they even try to merge, pull from the master and should resolve conflicts in their branch. Same with E.
Correct, but then C is doing a merge. They don't know exactly what D has been doing. They have a conflict. They need to make a call on it.
Yeah. But slowest person gets stuck with all the work. That's basically how it happens.
Yeah.
Which basically is you all the time. I get it.
If you've been stuck with something that's going to take you too much, then you're the one that's screwed all around.
Yeah, but a situation we experienced often is that in these cases the person who does the merging does a wrong merge, and then suddenly a feature that was working before is suddenly broken.
Well, you are working in a team, right?
then he should be
So you
fired.
should be talking to each other.
Yeah, well,
And also it should
Or
happen.
shot in the back.
I agree, but
well, this thing needs to be caught on a different level. So you can open the pull request and run all the testing on the pull request level. You can have all the tools that you as a developer will be able to run all the tests on your local computer. And this would be the same test. It would be run locally. Or maybe it will be slower or a smaller subset. But you have to have the tooling. So when you merge, actually you must be sure that it won't break the master. This is the thing that needs to, well, for hold this thing to work additionally. But then, even if I forget about testing, ideally what you can expect, if you always pull before merging, the difference between master and your feature branch is only what you have coded. So you've got all the tools in your hand to ensure that everything will be fine when you merge. If you don't do that, well, nobody can force you. Well, process can
but
force you.
there's always some nitwit who has no clue how Git works and says, "Oh, I'm gonna pull from master, woohoo!" And oh my God, I've got a conflict. I don't know what to do.
Well, there is a senior developer for that, a lead developer, or an architect who needs to help you. But again, these things are solved by education, or by process, or by both. But
Oh, I can read certain people. But yeah.
what else?
If your coworkers are constantly building fires under your desk, then you probably
Yeah, I've worked with those kind of people, and somehow management likes them. It's really weird.
Well,
So with this model, one thing I do not like so much is that the features are not independent anymore. So as for example, feature E, that has incorporated all the changes from feature B at this point.
yeah.
But suppose at the end of the line, when the end of the sprint, you're going to release a feature B, no, we don't want that after all.
Well, first of all, again, I believe this thing should be solved at a different level. So, for example, you can use feature toggling, and then it's easier. Or you can use a different thing called maybe git flow, where you can select which features will end up. I will show git flow as well. But before that, release branches. This is something that fits more into installed software. Story is the same. You make a release. Here it was a release, and then you create a branch, or tag it and then create a branch, and then, well, whatever you need to create a bug fix or hot fix, you're doing this and merge it back to the current development. And same happens with the second release. And here there should be a 1.1.3, and here 1.1.4. Well, but anyway, it continues like that. And while it looks nicely, there is a big problem here, because again, changes here are bug fixes that you create. Probably integrating them here might be a very tricky task. Might be not, who knows. But this is the problem with supporting legacy or older applications. It costs money and it costs a lot of effort. But if you have to do it, well, do you have any other choice? Git flow. Actually, this is what I also see a lot of teams using. I have some issues with the Git flow. It's not fully compatible with ideas of continuous delivery, but it can be if implemented correctly. The major ideas of the Git flow is that there are two branches, and this is like this thing that is so famous about Git flow. This is the thing that I don't like, because why would you have two branches? But anyway, it works in the scheme. There is development branch, where you develop anything, and you still can use feature branching. It's not shown here, but anyway, when you're preparing the release, you can just take the snapshot of whatever happens here, or merge the feature branches into release, and then merge it into master and create a release. Same happens if you want to create a bug fix. You create a branch from the release, create a bug fix, create another release, and also, well, merge it back into the development branch. So it supports a nice way for managing application lifecycle for installed applications. The only thing that you need to make it work is, well, you need to somehow being able to produce different builds and testing for development branch, for master branch, for every feature branch, for everything. And it might be tricky for some teams to arrange this kind of automation. But again, a lot of teams are using this, and especially a lot of teams that are not practicing continuous delivery. This is actually the perfect workflow to have, even if you don't have continuous delivery, because then it's better than everything else. It gives you control in what you're doing. Without feature toggling, you can select which features will end up in the release. And if you're, for example, a product manager, well, this is a perfect thing for you to have, and this is why they like it. And then continuous delivery, no, thank you. I've got my workflow. It works perfectly for me. So again, nothing bad about this, but
for this you need a release manager, right?
yes. So the problem with this is that you end up here 3 features are shown, but reality is that after a couple of months and maybe a year you got hundreds of features, and actually you can end up cherry picking. But you need to have somebody, and this is either a release engineer or a team lead, who holds all this information in their hands. And this is hard. This is really hard.
To automate all this, Atlassian? All the tools from Atlassian?
Atlassian are good at automating this, actually, yes. I believe they are the only ones I've seen that have a concept of good automation around Git flow. The rest, no. But again, this is what I'm telling you, it can be used. There is nothing really bad if you can automate it, correct? Finally, the open source. Just to show, because, it might be hard for people to understand what's happening in open source, because it's completely different development model than, well, I do in my general everyday work. Imagine, we've got an application, a library, or wherever, and we find a thing that we want to change, and we fork out of it. We don't create a branch, we fork. Then we do all our commits here. We squash all the commits. We need to squash all the commits because people don't want to see all of our commits, especially with commit messages like, oh, I fixed it, oh, I fixed it again, or something like this. So you squash those into one commit, describe it correctly, and then open the pull request, and then the pull request gets rejected.
Shouldn't you first, in the feature branching, also pull again from the main Git repository, or? Because if you start out at version 1.5, in the meantime it is at version 1.6.
Yeah, you need to pull. It's not shown here, but you need the same story applies. You need to pull, otherwise you won't be able. Again, more lines here, we will lose visibility.
Well, your previous image had way more lines, so I would expect.
Yeah, okay, I got your point. Yeah, you have to pull from the master anyway. This is you have to do it regardless. It's a default behavior. Before you try to do the pull request or merge request, just pull. This is something you need to do, and again, it should be automatic behavior for everyone. But the service like this, you create a pull request, and then the maintainers tell you all the things you need to change in order for the pull request to be accepted, or they tell them that it will never be accepted. But anyway, once you fix all the stuff and squash again, the pull request will be accepted, and you will get into the main line. And this is how the open source actually works. Squashing part is tricky for everyone who comes from commercial software development, because generally it's not part of the workflow, though it is a nice thing to have as well, even if you use feature branches, because you don't have 15 commits, you have 1. These features implemented, blah, 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 and you get nice history over that. But again, I haven't seen it working in real teams, but it's working for open source.
If you have a merge request, it pretty much comes to the same thing if you remove the branch afterwards.
Yeah, but then you leave a merge request there unless you rebase.
Well, I think in GitLab, the latest version of GitLab, they added an option that you can squash during the merge.
That is nice. I think they did it indeed, yeah. But then if you're using something like Stash or just Git, you have to do it manually. But there is a nice tool that can enable you to squash, because this is actually a nice behavior.
Okay, yeah, but the merge request already says the differences themselves. Plus you have the history of all the commits themselves. I think you have both.
Yeah, why?
I had a team lead on my last long-term project that spent every release being very OCD about the commit log and squashing every developer's commits now. Yeah.
Well, but it's nice to have somebody like this, but probably his life is miserable because he needs to do it all the time.
It made him very happy.
Yeah.
Well, also, he got me to create a bunch of scripts to help with commit messages.
Oh, okay.
Because he just couldn't stand the various teams' commit messaging.
Okay. More thoughts here? This is, I think, actually almost it. Just quickly some other thoughts that I had. Tagging. Tags come for free. Need just tag whatever you need, especially if you want to return to the version, for example, tag or something. Yeah, it's easy to do. Forking versus branching. To me, they're more or less the same kind, just a bit of a different. If you use really strict short-lived feature branches and you want, for example, to have releases, maybe forking is a nice possibility for you, because then your expectation is there is only one branch called master and the rest just feature branches. If there is no internal expectations, okay, I will find some outdated release branches here. And you can merge between forks anyway, so it's kind of almost the same as branches, just makes things a little bit more clear. But it's also scary because instead of one repository, you suddenly have 3, 4, 5, and more. But again, for some it might be working, and it might be a nice thing to just explicitly show that this is a different version of the product. Maybe there is a maintenance team who is doing this. Should not, but generally it can.
After forking, do you generally destroy the fork afterwards, or once you squash it?
Depending on why do you fork for. In open source model, you can leave it in your GitHub repository.
For some reason, within my organization, or within our team actually, we're very scared of having more than just a few repositories. So we put everything in just a few repositories because we basically use it as a document management system as well, which is really, really weird. But I've been trying to see if we can fork or branch, because it needs them. I need to educate them in those ways, and I'm actually wondering if it's best to have it to destroy the fork afterwards, or.
Depending what is it used for. If it's used as some kind of branch and you no longer need it, just go on and destroy it. But if it's something that needs to live for some time, like it's a release branch, but in it disguise a fork, it's forked in a separate repository. It will need to stay there for a long time until you stop supporting that version of the application.
Well, I actually have a question which is related to this. Is that because of I work at ING at a bank, so some tools are not allowed in certain systems, such as Git. So for some, on a production environment or an acceptance environment, we are not allowed to use Git. What we do use is an automated deployment tool.
Okay.
So what some of us do in terms of laziness is develop on our local machine, then create a few lines or edit a few lines, then push, then deploy the branch or the thing that you change. So that leaves you with a massive trail of commits. How can we it creates a metro map of everyone using different branches and stuff. Once we start doing that, how do other people do this? Is there a better way to do that, or squash everything, or
squashing and rebasing is actually.
I'm not really sure what the difference between squashing and rebasing is.
Well, rebasing is rewriting the history. So you're saying, okay, take commits that were before and put my commits afterwards, even though I branched out before and historically my commits were before. Just rewrite the history and forget about the branch instead of merging, having the merge commit. So this is one of the interesting things about Git, because branching and merging is easy, so why not use it? But it comes at the price of a clean history. If you want easy use for developers, there is no problem with it. But if you want to have clean history and search for history, well, you have to learn how to do it. Hard to give some advice with this knowledge besides this generic thing. I'm sorry.
We use the forking way for access control. So the idea for The bol.com is that every repository of every service is maintained by one team, and if someone else from another team wants to make a change, he forks the repository, makes a change, does a pull request. So the refill process is all taken care of by the team. So it's really easy to maintain access. It's only one team who needs access to the repository, and that's
And
it.
the rest can't fork.
Yeah, exactly.
Yeah.
And
It's
you-
more or less the same as open source model because the thing is the same.
Yeah.
Only maintainers have access to do something, but everyone can fork, update, even continue without creating a pull request, continue using their fork if they want to. It's bad, of course, but why not? If they need it. Same happens here.
And you can do the access control on the branches,
Yep.
but yeah, it's harder than.
You need somebody again. The problem is that if you have a couple of reports, a couple of branches, it's fine because people will know it. But when you have dozens of those, if hundreds, either somebody needs to know about that, and this is again, it's not fun job unless you have if you really expect it, like your example, and that's the guy takes all the pleasure out of it. Or generally it will be some poor release engineer or some, I don't know, somebody who will have to take control.
Script a lot of it.
So my preference here is to have kind of easy scheme that okay, we have only master and for example feature branches should lift and the rest go into forks or something. Then everyone's expectations are clear without opening the repository and going through the list of branches through history to learn what is even happening there. But it won't work for everyone, and it's only my internal preference. It's not that this is how everyone should do it. So.
And you need to keep your fork updated as well.
This is the same story as with the branches. Yeah. So to me, forks are kind of the same as branches, just more visible on the outside. Branches, if you want to hide this, branches are to go. If you want to make this visible, forks are to go. But this, to me, they are the same. You have to do if you're forking, you are just adding new remote. But you're doing the same process if you want to merge between branches. It's the same. The same if you know Git actually. Just you call it different. You call it not origin, you call it upstream. But yeah. Finally, this is my final thoughts. The pull requests and the merge requests, depending on which tool you are using. Anyway, the pull request is kind of the name that is used even if it's not GitHub and open source, even if it's not pulling. I would advise to create the code review process and to run tests when you're creating a pull request, because then, especially if code review is required for like one or two developers, like to pair of eyes on the code, it would be better that before human spends his valuable time to ensure that once you click the merge button, everything will be okay. And this is quite easily arranged, and this is what I really advise everyone to do. Arrange this process if it is required, or if you don't require pull requests, create a set of tools for developers that they can ensure that everything will be fine before they merge code, not afterwards. Afterwards is also fine if they can stop and fix it immediately. It's hard to enforce that, in my experience. It can, but it's hard. And it's better to invest time into preventing it than fixing. So finally, again, getting back to continuous delivery, this is why we're doing all of this. Keep the product releasable and build the quality in. These are two main ideas that I am communicating. And today, they were explained through the versioning and branching out. And this is actually, which takes away career. Focus on quality, speed will come. This is, again, this is something that happens to me. Quality has to be an integral part of the process. This was for the first part. Version each artifact uniquely, and version artifacts, not source code. And select the branching model that supports your product. There is no one good one, but I've shown some examples, and you can select and adapt those. And integrate frequently. This is why continuous delivery starts with integration, continuous integration. If you don't do it, and with Git flow, it can be tricky. You have to enforce some things, but you should do it. And this is actually it.
Thank you.
Yeah, sorry. You said at the beginning of your presentation you're not so interested in detail because the whole testing can be done. But completely missing from the picture, I think, is user acceptance testing, and surely that's an aspect that comes around.
Why can't you use acceptance testing in the same manner?
Yeah, I'm also in your initial part with the that you are asking a lot from your user base with the user acceptance testing, because they kind of demand an acceptance environment, because there's always, within ING at least, there's usually one or two people that actually decide whether something goes to production or not.
This can happen on a separate process, because here the process is of establishing quality of the product, internal quality. When you're finishing here, okay, you can have the next step here, acceptance environment for the managers and then production. But here you already clear that this build, if everything fine, can go to production. You did all the testing. Okay, I've got another presentation of 1 hour about how to do the testing in continuously and how to build it into the process. Yeah, and it's hard to explain it in 5 minutes. But anyway, here in the pipeline, you provide feedback to developers. There is a question, are we building the right thing, are we building the thing right? This is, are we building the thing right? But also, we need to test for the users. And if we need to split so we need to split application shortly into components or microservices and then test them in isolation. Because here, if we're creating the microservice, we can run into and test for microservice. But then later, a lot later, when we integrate, then we can run user acceptance testing. But we don't need to test everything.
You're not saying you want to remove the DTAP environments. What you're saying is that you want to change your D&T environments in a tons of D&T environments which are built and destroyed.
Yeah.
So that's a subtly different message than the first one you gave.
Still, I'm for the first message I get, because that acceptance environment is not an environment that is cut in stone and it's always here. You can have 15 acceptance environments. Just what's the problem with that? You can have as many as you want. You might not have for some of the parts of your system acceptance environment at all, because this is a backend and nobody has a clue how to do user acceptance testing on the backend. For example.
In a normal world, having more than one or perhaps even two acceptance environments would be really weird. Because that's the place where your final...
If multiple people need to give a go, if they're located in different parts of the world, why can't they have their own acceptance environment? You have exact version of the application, you create environment with exact theme, the very same thing, it can be 3, 4, 5 environments acceptance. They might not even be called acceptance environment. They can be environment for Chris from US, environment for Mark from India. He needs to give a go there.
We start a user environment per user story.
This is also
so every user story gets its own environment, and it needs to be checked by the user before it's merged to master. Because when it's merged to master, it's on production.
Yeah, okay.
So you use that environment to test everything.
You guys have a lot less bureaucracy to deal with than I do.
Well, the main message
working at a bank has its downsides, and one of them is bureaucracy.
But one of the main messages is stop thinking about this development, test, and acceptance environment as the service that you, well, I understand why it happens. Before you needed to get a virtual machine or the server, you needed to wait for weeks to get it, and then you hold it like forever.
That's
in the modern world, this is no longer the case. You can have, well, again, given some assumptions, you can have as many environments as you want, as many times as you want. So you can have still an environment that will be used for acceptance, but just don't call it acceptance, because then things will stay there forever, and it will cause trouble.
Yeah, I think you can ask the question, why do they need the bureaucracy at this moment? Or do they need to just audit what has been done? Because
the point at a bank is that it's really tricky and really complex to keep everyone out. Because before I have access to a server, I have to specifically define which parts of the server, which application, which commands, which non-personal accounts, which personal accounts have access to a certain environment. So once I have an acceptance environment, I'll make damn sure it stays there. I will not destroy it whatsoever, because it will take me about a week or two to get it back.
Mm-hmm.
And then the host name changes, then I have to change every single bit of documentation I have about that thing, then have to resubmit it to the internal authority, which takes again a few weeks. So it'll cost me a month to get that thing back online.
Yeah, well, that was kind of the point of my presentation as well. Just make those environments ephemeral within a certain amount of nodes, which are always there. But
exactly. The annoying thing is about, at least in my organization, is that piece of environmental infrastructure where you can just build and destroy environments, which is awesome, has been promised to us like 15 times now. It was actually built, except for one very critical feature, which is to destroy and rebuild the environment with the exact same host name and directory structure, etc. You can get a new one within a few hours. It'll have a different host name, which takes me back into the local authorities saying I have a new host name. I have to redeliver all my documentation again, but change the host name, which takes 2 weeks.
Yeah. That service discovery. That works.
Yeah, but keep in mind that on those machines are your personal data, because I work at the bank. I know a lot about you.
Okay.
So you don't want every single.
But it can still be in your secure infrastructure.
Otherwise,
Yeah, I know, but still.
Well,
Like you said, that sometimes I want to be a web developer that just has a really simple way of.
that is easy. Okay,
Yeah.
you probably will have to go on call, but the rest.
Yeah, exactly. I'll be on call, but
What can go wrong? Like on call sounds simple. Well, but anyway, just to a bit about ING. So, well, on the meetups there are people that are presenting from ING, and there are some guys from IT for IT. Again, I'm not sure about internal structure, but they claim that they got all the Docker clusters and they can provide it. Maybe for
yeah, but
different
then
departments.
But then
I don't know.
for
Really.
IT does not contain any data that is confidential.
Sorry, I don't know internal structure of
No,
ING,
no,
so I have no clue.
Some, like say IT for IT has what they call a confidential level 4, which is, I don't know, no one cares if it gets stolen or whatever. I work at confidential level 1 or 2. So that means I have to define every single bit of data that I have on a machine. And data
Okay, well, I've got another argument. So a month and a half, there was a software circus meetup in ING in Balmer. And there was a CIO of ING there giving 15 minutes talk to tell how ING is going full forward towards DevOps and continuous delivery. So it might happen soon.
No, we're there, except one piece of DevOps that ING still hasn't. No, we actually went to DevOps, and now we're not doing DevOps anymore because that term doesn't come around that often. We're now doing the entire Spotify model with tribes and squads and stuff. Because one of the things that they could never get to work within the DevOps system is get infrastructure to join teams. Because those are two completely separate worlds. So because one of the first issues that we had at DevOps team was, okay, so where's our infra? You know, we have ops, we have dev, where's infra? Because I need a machine and I need it now. Oh no. Infra works at a completely different plane of substance of existence.
An API, right?
Yeah.
Yeah.
This is actually, you have to have an API.
So then someone thought, let's build a cluster that gives you nodes on the fly, and then queues got stuck and everything failed to work. So they failed to implement a feature because it costs so much money. And everyone's like, oh my god. And then you hear like these awesome projects within ING with the Docker clusters and get your things up and running and within minutes, and it works. If you don't have confidential data, because then you can't put your data on there.
Yeah.
So from the outside, they have a lot to say, because, and I've been to teams within ING that goes like, oh, we don't do anything with defining where your data is and whatever. And I was like, what the? I want that too. Give it to me. I need this.
But if those are the constraints, then maybe it's just not feasible to go the continuous delivery route. It's all a matter of how much pain are you feeling, how much value do you want to generate. If it's not going fast enough, you make it faster, then you remove the obstacles. But well, if you have these constraints.
But for ING, it's more easier to say we're doing something new than to actually fix the old system. Because the old system works
always like that.
because we could get a new machine within a week, which is cool because now it takes about a month. But the only critical feature for us as a DevOps team, or not a squad right now or whatever, is I actually do not know for which team I work, which is kind of cool.
But at least you know the tribe.
No, because the tribe has switched like 3 times in the last year. The team hasn't, but the tribe has. But the main feature as a DevOps team was I want to start anew. You know, I want the exact same machine, exact same specs, but delete everything from it and re-image that thing. Just re-image. I want the same host name, so I don't get into crap with the local confidentiality authorities and stuff. Nah. So now we're building some kind of Docker structure with fancy new features and stuff. And like, yeah, could you please fix the old one, because we're still using that.
Alright.
So that's why this image triggered me quite a lot, because give this to me.
Not for enterprise, so sorry. Will be available.
Maybe you should have put that like in
Will be
the
available at a later time. You know how it goes. Asterisk.
Not for enterprise.
So if you apply it ING, you better make sure that you ask about the confidentiality level, and then
Exactly,
what
yeah.
kind of stuff you can do.
And now, if you do apply for a job at ING, make sure it's like a new hip team,
Yeah.
because they get they skip all the rules, and they'll probably get caught up by the authorities later on, by the central security authorities. But for now, apply for a new hip team.
Okay.
Well, I can tell you what we are doing with the, for example, with the branching model.
Mm-hmm.
If you can go back to the feature branch.
Yeah.
So with feature branching, every time you start a new feature, and we started the whole test environment for your feature, which only contains your feature and nothing else. And every change that you make, every change that you push to a Git, gets automatically deployed to that new version. Is built via Jenkins build, is tested with any test that you wanted to run against it. A user can look at it with via an URL. Can do whatever he wants with it.
Does that, like when you commit in a feature branch and you say you create a feature or a feature branch, at that point a environment is spun up?
Yeah,
and
we create a branch for you. We spin up a test environment, we spin up the Jenkins jobs.
That's fucking awesome.
Have a look.
Yeah.
So there is a presentation. By
Yeah, I will link to the
Pavel.
presentation in the meetup notes.
Okay.
Where do you
Yeah,
work?
please do.
Where do you work?
Bol.com. And for each so each feature gets that environment. You can do whatever you want. And whenever a feature gets merged to master, it has to check the definition of done. It's basically in the simplest way, it's just checking that the feature branch is up to date with master, and there was a deployable to an environment that worked. And if that's okay, then we merge it via a pull request. And after that one is merged, it's pushed out to all the feature branches that are open. So all the changes that are in master are pushed to all the feature branches, and it's merged as long as Stash tells us that it's mergeable. And if it's not mergeable, then the user has to update, has to fix the conflict with himself. So
That's pretty cool.
all the issues with conflicts are in the feature branches and not the master.
Which makes sense.
Yeah. Which is the reason why we don't need versioning, because if it's on master, it's deployed to production automatically. We don't even have a build on master, because the Docker image that is created in the feature branch is equal to master. So we just retag the Git of the Docker image that we had on the feature branch. We retag it to a different to the production brand tagging, for example, and then we redeploy it.
That's pretty cool.
And that's it.
For me, the standout feature of the Mayfly is the definition of done as a code. I'm not sure how to call it correctly, because this is actually what is really nice and what, I believe is great, because teams have a tool to describe programmatically definition of done and then automatically check against it. This is kind of perfect.
Yeah.
Was it open source? Because I think
No,
it
not
was a
yet.
promise.
we want to open source it.
Okay, so still waiting.
Yeah, still waiting. Yeah,
Still
we
waiting.
started a bit later, but last year we were waiting for the open source policy to be signed by the management.
Yeah.
And is
So
it
that's
signed
nice.
now, or?
And this last week we completed it, and it's now getting spread out that we are able to use the open source policy. We may release stuff as open source. So that step is taken, and now we need to take the time to actually open source it. Prepare it for open source.
Based on GitLab news?
No, it's currently on stage.
What?
Just because when we started with Mayfly, GitLab didn't have the features yet, and we didn't want to wait for them to implement it. Currently, they have all the features that we need. We have the GitLab Enterprise Edition, and we still want to implement the GitLab Enterprise Edition API also for Mayfly.
And Mayfly is the name of the project.
Yeah.
And the application.
And how big is the development team?
We developed it with 6 people.
How many?
6.
Dedicated to that project? Or?
No, we share it with 25 other services. So we have a lot of other stuff to do, but Mayfly is a big focus to us. So what my team does is basically providing the build environment and build tooling for developers. So we maintain Jenkins, GitLab, Stash, SVN. It will get deleted in June, July. So almost get very good.
You don't want to know how much legacy stuff we have running within I.
At least it's not CDS.
Yes. So yeah, we have a lot of other stuff to maintain. Actually, I will post the video from our Mayfly talk once we meet.
Yeah, cool.
So I already listed some ideas that I could post. So I heard questions about how the rebasing worked in Git. I got a great video from some Linux conference in Australia. He explains Git for 4-year-olds.
Could you please send me that link to him as well? Because for some reason he hates Git.
I will put it on the
But basically a bit because you suck at it. So.
He explains it perfectly. And
Use the TFLs.
model.
Yeah.
Which one, sir?
Spotify model.
Yeah. Well,
That is
Or
why
you're
you are
using
working
it.
on.
We also use
no,
it.
no, we're abusing it. We're not using
Well,
it, we're
everybody.
abusing it.
So at Bol.com we're using the variant of it.
Yeah.
So we have a platform space where the teams provide services for the developers. And then within the developer teams they are split up for functionality. Yeah. We basically use it also. Any the Mayfly presentation.
Yes.
I can also post the video of me talking about testing if you want, and then describe
maybe you can do a
this
section on that,
build
next
test
time.
release a bit more.
Because that sounds really interesting.
Does it contain an asterisk saying not for enterprise or no?
You can say the first slide, use common sense.
Nice. So that means not for enterprise. Okay,
Yes,
that's
Jordan, please leave the room.
exactly. Please leave the room.
Okay.
Cool.
Thank you.
Thank you.
Thanks.